The 60-minute death sentence. Venus will dissolve a standard scientific instrument suite in less than 60 minutes. While the marketing narrative focuses on the search for phosphine, the actual engineering hurdle is the 460 degrees Celsius surface temperature and a surface pressure of 90 bars. Rocket Lab's Venus Lifefinder is not designed to land. It is designed to survive a high-velocity plunge through concentrated sulfuric acid clouds. This mission represents the first private attempt to crack the Venusian atmospheric entry problem with a probe weighing just 20 kilograms. To understand if life exists in the clouds, the probe first has to survive a kinetic energy discharge that would vaporize most composites. This thermal management begins with the specific geometry of the heat shield. The 11 kilometer per second wall, the probe hits the atmosphere at 11.2 kilometers per second. At this velocity, the compression of gas in front of the shield creates a shock layer hotter than the surface of the sun. Unlike NASA's heavy flagships, Rocket Lab is utilizing a high-density carbon phenolic ablator. The material is designed to char and flake away, carrying heat with it in a calculated sacrifice of mass. The margin for error is thin. A 2-degree deviation in entry angle either skips the probe back into space or causes a structural collapse from excessive G-loading. If the structural integrity holds through the deceleration, the next threat is the chemical composition of the descent path. Navigating the acid furnace, between 48 and 60 kilometers above the surface, the probe enters the primary search zone. Here, the atmosphere is 85% sulfuric acid. Standard aerospace alloys would corrode before the sensors could calibrate. To solve this, the engineering team replaced traditional metallic seals with PEEK plastics and Teflon coatings. The internal pressure vessel is a titanium shell, but the windows for the laser instruments are made of lab-grown sapphire to resist the corrosive fog. This material choice is a direct response to the specific chemistry of the Venusian cloud decks, where the search for phosphine actually takes place. The 20-kilogram constraint. Mass is the primary constraint for a small launch mission. The entire science payload is a single instrument, the autofluorescence nephelometer. It weighs roughly 1 kilogram. By stripping away cameras and multispectral imagers, the team maximized the mass fraction for the protective shell. It is a minimalist approach to planetary science that prioritizes a single data point over broad surveying. This trade-off is the only way to fit a deep space mission onto a small-lift Electron rocket. The era of scout science. The Venus Lifefinder mission proves that planetary science is shifting from billion-dollar multi-decade flagships to rapid attrition scout missions. By solving the entry physics and acid resistance problems within a 20-kilogram envelope, Rocket Lab has demonstrated that the barrier to entry for the inner solar system is now a matter of material selection rather than massive government budgets. This mission confirms that low-cost titanium shells and sapphire optics can survive the most hostile chemistry we know of, provided the goal is high-intensity data collection rather than long-term survival. The success of the carbon phenolic heat shield during the May 2026 entry window essentially commoditizes Venusian atmospheric access. This shifts the bottleneck from launch capacity to instrument sensitivity. Watch the May 30th data downlink for the specific fluorescence signatures that will determine if this minimalist engineering was enough to find a biological signal in the acid. Subscribe for more